I could have it like this as well too. 4b minus 3a. So that's the two ways to write it. You can have it either as minus 3a plus 4b or 4b minus 3a. The next one now, f to h. F to h. So we're going from f to g and then g to h. We already work out what gh is. So if you look at this now, going from f to g, okay? If here is 3a, here is 3a, here is 3a, we know that g to f is 9a. This whole thing is 9a going this way. So that means if we're going back from f back to g, that must be minus 9a. So we could write this as saying f to g plus g to h. So f to g is minus 9a plus g to h, which is 12b.
So teach.
Uh-huh.
If the arrow will point in the opposite direction, it'll go from F straight to H.
If it were going from f to g, if
If
we're
the
pointing that
arrow,
way,
the arrow for C pointing
put
right.
the right this way, right? You mean if it were
Yeah,
going the opposite direction?
yeah.
Yeah, if it were the opposite direction, that would have been positive. So if it
No,
was
I
like this,
mean no. You see how for C it got FH right here in the blue, and then it got arrow
right?
pointing right. If it were
Uh-huh.
if the arrow pointing left, you ought to go from F straight to H.
Oh, yeah, H to F. You want to go H to F. But you wouldn't write it like that. If you want to go from H to F, they would write it like this. H, F, and then on top, they would do this to say H to go to F.
Right.
Yeah?
Yeah.
So you wouldn't do it, you wouldn't write it the other way around. You wouldn't write this point in the other way around. You always like try to show it like how you read. You tend to read left to right in English and most languages. Unless you're doing Arabic or something, you're reading right to left. Because we read left to right, it just makes sense to go that way, to keep it that way. So that's why you see it pointing that way. Make sense?
Yeah, yeah.
All right. So the next one now is we could write this like put a positive in front. You got two ways to do this. So whoever did it this way, it doesn't matter. Once you got the same concept. So 12b minus 9a or 4b minus 3a, whichever one you end up using as your answer, either one would work. They mean the same thing. Here I'm adding 4b and taking away 3a. Here I'm taking away 3a and adding 4b. It's the same thing. I just saying it backwards. So then this now, m to h, m to h. If I'm going from m to h, that means I'm going from m to g. So we're going from m to g plus g straight to h. I have m to g, then g straight to h. Okay? So m to g is minus 3a. Minus 3a plus gh. Gh is from here going to h. And what we have for gh? 12b. So we could say that is 12b.
But teach you only gotta look at it in one direction. You couldn't go like M to F then to H.
M to f then to h, yeah, you could do that if you want. You would get the same answer.
You just do what more comfortable and shorter to you.
Exactly.
Oh,
Yeah. You never do vectors before, right?
yeah, yeah.
Yeah. So when you're doing the vectors, you could go either how. You could go like if I have one go mg, then g to h, or m to f, then f to h, I get the same thing. So say for instance with this one now, m to f, right? Then I could go plus F to H. So M to F is 6, 8, right? And FH is this here, minus 9A, and then 12B, however there. We could put this here, 12B minus 9A. All right, now when I simplify this now, it could be 6A take away 9A plus 12B. This got turned to negative 3A plus 12B. You see?
Oh, yeah.
You get the same answer. But you see now, the reason I would have taken this route is because it's just like easier, you know what I mean? Like, okay, I could see obviously that M to G is 3A, and then I know that this is 12B, so I kind of cut out all this work. You see what I'm saying?
Makes sense, yeah.
Because you could answer it like that to the harder way, but either how you don't get a trophy for answering a question the hardest way. You see what I'm saying? So you just try to make it as efficient as possible. Okay?
Yeah.
So the next one here now, we need to see if they have geometric relationships. So whenever we're doing something like this, we're trying to figure out, one, does it have a scalar multiple? Like, are they scalar multiples of each other? And then after that, we got to determine whether they're parallel or collinear. Whether they're parallel or collinear. So the next thing is whether one is two times the size of the other, 3 times the size of the other, etc. Okay? So the first thing we need to do, first of all, is get what 2 of these are. So FH, I'm going to say FH is essentially equal to 12B minus 9A. All right? And then after, I'm going to say MN is equal to 4B minus 3A. So this is the kind of style of questions you usually get for these kind of questions. They always like ask you to find this, find that, then prove the geometric relationship in some form or fashion. Okay? So this way now, we ask them now, how can we compare these two? Like, how do you know like the size, how big one is from the other? First of all, we need to see the scalar multiples. So unless we don't figure out that it's scalar multiples, we can't do anything. So in order to do that, we need to factorize. So if we're looking at this, we're looking at 12 and 9. The highest common factor between 12 and 9 would be 3. Okay? So the highest factor between 12 and 9 is 3. What we're going to be left with then is 4b. All right? Because 12b divided by 3 would give us 4b. Next thing, 9a divided by 3 would give us 3a. All right? Now, when we look at this here now, we realize that we have a 4 and 3, but there's no higher common factor other than 1. So there's no need to write it, but I'm just writing it for like demonstration purposes. So we say the highest common factor between these two is 1. So we have 1 there. So that means 4b divided by 1 is itself, minus 3a divided by 1 is itself as well. Now, if you look at these two vectors now, you would realize that, hey, this here, this 4b minus 3a is the same as 4b minus 3a. Two of these are the same. So because these are the same, we know that they are scalar multiples. Okay? They're scalar multiples. So if they're scalar multiples, now I could test for 2 things. To test whether they, what size they are of each other. Then I could test the collinear or parallel kind of aspect of it. So what I would need to do is look at a number in the front. So if you look at this number in the front, we have a 3, and in here we have a 1. So it's like we're saying now 3 divided by 1 gives us 3. So if I'm looking at it from this way, I'm saying that FH is 3 times the size of MN. So I could write that like this. FH is equal to 3 times the size of Mn. That's the first thing. So if I was to write that in like a sentence, I would say FH is 3 times the size of Mn. And I know that because they're scalar multiples, they have to be scalar multiples in order to do this comparison. So that's one geometric relationship. FH is 3 times the size of Mn. The second one is they do not share a common point. Because they do not share a common point, I know that they are parallel. If they had shared a common point, so for instance, if this had say FH and this say Fn, I would know that both of them are collinear. If it was FH and MH or something, both of them got H, I would know it's collinear. But in this case, FH, I don't see FH anywhere here, so I know they are parallel because they already passed the scalar multiple test. Once you pass this test, you're either parallel or collinear. So in this case, you would say that they are parallel. All right. And then the thing about this is no, not only can we do that, but if you look at this, right, you end up in a situation where if you have a diagram, you could prove it. So if you say from Mn, and then we say FH, right? No, I already have this drawn, F to H, but say if I draw M to N now. You see, if you look at this line, if I compare two of these lines, you would see that they are parallel. This is F to H. See? So essentially, if you look at this, it's almost like saying, I could take this here, and 3 of these could fit the cover here. So let's say if I had to do a copy of this somewhere like the same length, that's covering like here. So it's just about this size. So covering 1, 2, 3, 4 spaces. So I roughly saying this is 1. This is 2. And then this is the third one. So if you look at that, essentially Mn, this here represents Mn. It takes 3 Mn's to make the FH. Okay? And they still parallel to each other. Look how we're going in the same direction but never touching. So they are parallel to each other. Okay? So this here is the one with a triangle. The next format is get it in would be a parallelogram. So I'll let you guys take a picture of this if you didn't have it, and then we'll check the parallelogram one. All right. So let's try a parallelogram. Look at this one. So we go through this one together, then I'll give you one to try. So if you notice this, it says LMNO is a parallelogram and can be represented as seen below. So I'll get you started off on 1, and then after you'll try to do the rest. So it's saying LMNO is a parallelogram and can be represented as seen below, where O to N. O to N represents 12A, and O to L represents 12B. O to L represents 12B. Now we're saying that T is a point on Ln where LT to Tn is in a ratio 1 to 2. Remember, we have our famous example of how we do this. We use chairs. So for instance, we're saying that if we're going like this, we're saying this represents LT and Tn. I know that the whole line is L, and this here is N. So we are saying that T has to fall somewhere here. However, if you look at this number 1 and 2, that means that this has to be split into 3 items. How did I get that? 1 plus 2 is equal to 3. So I know it's sharing 3 things. Okay? So now I'm going to pretend that we have chairs on this bracket here. We have 3 chairs. So based on this statement, it's saying that LT represents 1 chair and Tn represents 2 chairs. So I need to drop the T where that makes sense. So if I drop the T here, L to T has 1 chair and T to N has 2 chairs. So that is correct here. So I could say now, L to T, if I want to write an expression for L to T, I could say that, let's write it, where could we write it? Let's write it here. So I could say that LT is equal to 1/3 of ln. Okay, so LT is this. From here to here is 1/3 because it's taking 1 chair out of the 3 chairs of ln. And then Tn, how many chairs we got in Tn? Tn got 2 chairs out of the 3 chairs for the whole of ln. So I got 2 expressions. One for LT already is 1/3 ln, and one for Tn, which is 2/3 ln. All right. The next thing they say, R is the midpoint of OL. So that means R must fall somewhere here. Okay, that's R, midpoint. Now the question says, write an expression for Ln. So if we write an expression for Ln, we need to know how to get from L to N. So I'm looking at Ln, and if you look here, we're going from L to O and O to N. Those are the only rows that we have named so far. So in order to get from L to N, we need to go L to O, then O to N. So I need to say,
can I go from L to T and T to N?
okay, so if you want to go from L to T, how you gonna do it? What you gonna use?
So I can go from L to T and plus T to N?
You could do that, but how you gonna do it? Tell me how you gonna do it. Like, how would you do it?
Thing on our values, I think.
Right. Thing on no values on it. So then you would have to go work out what them values be first, then use that concept. You see what I'm saying? Right. So you use the ones that actually got values on it already to make it easier for yourself. You see what I'm saying? Because what you saying, you could work out L to T, you know, and work out L to T, then work out T to N, and then add them together. But I give you more work to do. You see what I'm saying? So we're going from L to O, which would be easier for us. We go L to O, and then we add that to O to N. All right. Now, L to O, we have here, from here, it told us that OL was 12B. So if OL was 12B, that means if we go in the opposite direction now, from L to O, it must be minus 12B. Okay, it must be minus 12B. Then we're going from O to N. So we're going into the direction what ON is, which was 12A. So that means O to N has to be 12A. All right. So we could have it written like this. From our last question that we were looking at, remember we swap them around to show that, you know, it could be the same answer. So we had minus 3A plus 4B, and we swap it and say it could be 4B minus 3A, just so we could avoid having a negative in front. So we could end up saying 12A, and we say minus 12B. Okay, so that would be our answer for this. Now, they're asking us to do LT. We need to do LT now. We need to do LT now. So if you're doing LT, we got to figure out a representation for LT, and that's what we did earlier. So if you look earlier, we said LT is 1/3 of ln. So L to T is 1/3 of ln. So even if we look here, we already make that dot. So L to T is 1/3 of ln. Now, this is where you need to make sure you're looking at all your previous questions when you're answering. We already figured out what ln is. So we don't need to sit down here and go, okay, I need to go from ln now. 1/3 of ln, that means I need to go from here to here and here to here and find 1/3 of that. You already calculated. So there's no point in going and trying to do it all over again. We already got it there. So we could just work it out one time. So if you look at it here now, we're saying LT, that would be 1/3. So we're saying 1/3 of this here, because this is from our previous question. Okay, so we're saying this is where we're going, 1/3 of 12A minus 12B. So we're trying to find 1/3 of each of these numbers. So another way of saying that is 1/3 multiplied by that. So we're saying here 1/3 using distributive law, 1/3 times 12A minus 1/3 times 12B. Now, if you think of 12 as a fraction, it's the same as saying 12 over 1. So we could say 3 into itself goes once, into this goes 4 times. Same thing here, once goes into this 4 times. So then LT is equal to 4A minus 4B. That's our answer for LT. And if you compare it, you could see that this is 12A. This here says 12A, 12B. And this here says 4A, 4B. So if you look at it, 12A, 1/3 of 12 is 4. And 1/3 of B, 12B, is 4B. So you can see that that's the answer we're looking for. Now the next part says LM. So LM kind of like easier now because it's only one thing we're trying to get now. From L to M, remember this here is a parallelogram. So if this is a parallelogram, that means O to N would be the same as L to M, as well as OL has to be the same as N to N. So I could just simply say that LM in this case would be equal to 12A. And I could write here 12A. All right, so that's the answer for LM, 12A. Now the next thing is saying T to M. T to M. We got 2 ways we could do. Well, in this case, we got multiple ways. You could go T to L, L to O to N to M. You could go T to N to M, T to L, L to N. All right, remember, when we're doing these kind of questions, we don't get an award for answering it the hardest way. So we try to answer it with things that we already have and what's easy for us. So if I'm looking at this now, T to L, do I have anything with T and L? Yes, I got this. I got this one here already. All I need to do is the reverse of this. Because if I'm going to L to T and L to T is this, that means TL would be the opposite of that. Then the next thing I would need is L to M. Do I have that? Yes, I got it already. So there's no point in me trying to go and work out T to N when I don't need to do that right now. And then do it with the NM. I just have this already. All I need to do is change the signs and I'm good. So for instance, with this one, now we're saying T to M. So we're saying T to L plus L to M. All right, T to L plus L to M. Now, if I'm looking at this now, I could say T to L. What was that? T to L got to be the opposite of this. So if this was positive 4A, that means I need to say here now minus 4A. And if this was minus 4B, I need to say now positive 4B. Okay, that's what I need to say now. And then now I need to add that to whatever LM is. So in this case now, LM, we figured out that LM was 12A. So we could even write this here so we could remember. And all we need to do is add that plus 12A. I already put a plus already. So I just need to go 12A. Now I could simplify it, group the like terms together. So we got the A's here, group the A's here. So that's like saying 12A minus 4A plus 4B. These here would simplify to 12A take away 4B, 4A, sorry, that got turned to 8A plus 4B. That's the answer for TM. 8A plus 4B. That's our answer for that. So the next thing we need to do now is RT. So let me see here. No. Shift this down. So we can do RT now. Should probably put it over here so you can see it. And then put this question here too. So we're doing RT now. RT. Do we have anything with RT so far? The only thing we have is L to T. Okay, we have a L to T. So there's no point in going R to O, O to N, then N to the T. No point. No point in doing all of that. You just keep it simple. Going from R to T, just keep it simple. So that means I'm going R to L. So R to L plus L to T. Now remember, R to L is half, because we said R here is the midpoint of OL. So if that is a midpoint, we are saying O to R got to be 6B for this little piece here. This here has to be 6B. And from here to L also has to be 6B. Okay, so that means R to L is 6B, and L to T, we already worked that out, which was this.
So teach.
Uh-huh.
So even if they mean give you 6B, you could make that yourself.
Right. You make it yourself because look at this. If it's saying R is the midpoint of OL, I know that OL is 12B, right?
Yeah.
So if I only go in halfway, how much I gotta be using?
Half of 12.
Right. Which is
6.
6B. It makes sense? You follow that, right?
Yeah, teach. So you're sure I could do that, and then don't tell me that I wrong.
Positive.
So I
Positive.
can just say half of 12B.
Yeah, I could do that too. Like say if you had that and I put
Okay,
here.
I think I'll go that way because I want to tell me that I wrong.
But check this out. No, if you do half of 12B, right?
Why I say that though? Because safeties of people doing some bad marking it and see me them wondering where I get that from. I don't mean really to understand it. That's what I mean.
Right, so you could do it like this first then. You put on the half of 12B, and then after you write it. And the next thing too, like if you check the reports, what they say, like when students label the diagrams, once they label the diagrams and read from it, it's fine as well too. So if you got it on your diagram, you could, they could see that you got it from there by splitting this as well too. So if you want, you could always write it like this first, and then go like that. But you see, we already had it on the diagram. So we put it like that. But if you check it out, just to be sure then, you write it like this first and show them that half of 12B is 6B. Then you could work these out, right? And then now when you work this out, you will end up with 6b take away 4b is 2b plus 4a. That's your final answer for that. Make sense?
Teacher got any kind of cheat sheet I could deal with, cause I know myself, and as much as I thought I practiced, nobody can remember every single thing.
You can remember everything, but you know, it's still like as you keep practicing, that's how you retain the information. See what I'm saying? Once you keep practicing, that's how you retain information. So you got to be actively practicing.
You still gonna end up forgetting something.
You gonna forget some stuff. You ain't gonna remember every single thing. But your best bet is to practice. Best bet is to practice. Just like if you service in a car, right? You know, sometimes you might forget to do little things. The thing that you ain't know how to do it, it's just that you ain't see it in a while and you forget. You see what I'm saying?
I never forget so fast.
So that means you practice good enough then.
You got feel.
You're right. So if you practice enough, the chances of you forgetting gonna be really small.
Wow, catch on. That is one topic. But no, you got multiple topics in medicine. That's one topic.
That's true too. That's true too. But if you keep practicing the way that you increase your chances of getting it sorted out though. So always remember that. All right, so let me show you this last one here now. Then I'll give you guys one to try just like this. So with this now, we're saying
Zoom that out. Zoom that whole question here.
Okay, good. You got it?
Yeah.
All right. So with RT and TM, we need to see if there are two geometric relationships between these two. We need to figure that out. So in order to figure that out, we need to compare the two of them. So we can compare RT and TM. Okay, RT and TM. Now, if I'm writing RT over and TM over, I need to make sure that they align. So for instance, I got TM here. So TM was equal to 8A plus 4B. And then now RT, I want to write RT in the same form. So when I say the same form, notice how I have RT here as 2B, and then I have 4A. So since I want it to look like this, I gotta write the A first, so it gotta be 4A first, plus 2B. All right, now you guys know what we have to do with these letters. We always have to factorize. Okay, just like we did last time, factorize first to compare. Because if we factorize and we realize that they have the same vector expressions, we know that they are scalar multiples of each other. So if we're looking at this here now, we know the highest common factor between 8A and 4B. The highest common factor in terms of the numbers we would get would be 4. Okay, 4 would be the highest common factor here. So I say 4 outside, bracket. If I say 8A divided by 4, that would give me 2A plus just B. If I walk this back just to make sure, 4 times 2A is 8A, 4 times B is 4B. If I come over here now, I'm trying to factorize again. What's the highest common factor here? 2. 2 is the highest common factor between these numbers. So I bring the 2 out, and then what I'll have here now is 2A plus B. So if you look at this now, we're back in that situation, we realize these vector expressions the same. So because they are the same, we know they are scalar multiples. Okay, scalar multiples. Now, if they're scalar multiples, now we could compare to find out, you know, the size of one to the other. So we're trying to see which one is bigger. Obviously, we know this one is bigger because it has a 4 here. This one has a 2. So we could say 4 divided by 2 is equal to 2. So bearing that in mind, since this first one represents Tm, we are saying that Tm is twice the size, because we get it from this 2 here, twice the size of RT. So that's our first geometric relationship. And if you look at this now, which one do you have to do? Tm and RT, right? So Tm and RT. So that's the first ones we do. Then the next thing we need to do is compare to see they have the similar points. Now, if you look at this, you realize that we have T here and a T here. So in this case, now we could actually say, oh, well, they share a common point, which is T. So that means Tm and RT are collinear. All right? They are scalar multiples of each other, and they share the same point, which is T. So we know they are collinear. All right? So I'll go on the diagram and explain what that looks like.
But look, the T is in front of the M, and then after the T is after.
Doesn't matter. Doesn't matter. Share the same point.
So it could
No
have
matter.
T's, it could have 2 T's on top of one line.
Well, no. What happened is this. If you look at this, you see how we got Tm? We got Tm here. T to M. You see this? T to M is one comparison, and R to T. You see? So if I draw a line now from that, I'm going from R, passing through T, going to M. You see what I'm saying?
Yes, yes.
So then now they share in a point T. Okay? And remember, we say that RT is twice the size of this. So basically from here to here, this could fit 2 times here. If I was to take this same length and put it and like double it, that could fit here twice. So that's our first statement. Tm is twice the size of here to here. R to T is twice the size of Tm. And they are collinear. They share in the point T. So you see that T to M and R to T. What point they share in? T. That's the point that they share. Make sense? All right, so let me give you guys one to try to start working on. And then tomorrow, let's feel we gonna start working on, we gonna work on answer a few past paper questions that involve letters. So as I tell you guys, the thing that makes these kind of questions difficult is when it involves fractions. When you end up having, instead of, you see how we had nice numbers here? By the way, take a screenshot of this part here. You see how we had like nice numbers here? When you're doing like with fractions, it end up like we're trying to factorize 1/3 of this and that and so forth. That's the only thing that is starting to make it a little tricky. But other than that, once you like grasp the general concept of vectors, it ain't too bad. All right, so I want you guys to start working on this. So similar concept, same vibes going on, just different numbers. Let's see how you guys get on with this.